Hey, welcome lovely people. I'm Konstantin and today I'm gonna talk to you about 3D and all the amazing things that you can do with it. So let's begin. Here we have an example on how to do some 3D. So it's pretty easy. We can start by creating a shader where we define several attributes. Then we're gonna pass a specific position to it. We're gonna then create another shader. We're gonna initiate a demo, as you can see, so we can select an element, some context. We can also use some fallback, some alert, and check various things. Then we can import the shader again. We can compile it. We can attach the shader. We can validate the program. Then we have a few vertices. So yeah, and then a buffer, another few matrices. So yeah, as you can see, it's pretty easy, pretty exciting. No, just kidding. It's actually pretty boring and not the most exciting thing ever. This is why we're gonna use something else. Oh yeah, and let me also show you how it looks like. So this is basically it. Yeah. As you can see, it's a spinning cube. So yeah, it's pretty simple. You don't really have a lot of shadows, a lot of color. It's pretty bare minimum. But yeah, we still had to write like 130 lines of code. So it's not that trivial and the result is kind of okayish, but yeah, was not the most exciting. So as you can see, WebGL is nice because it can help us create this kind of cube. And at the end, this is still the standard on the web. Meanwhile, it's not that friendly to use. So that's why we're gonna use something else. But just before, we can also admit that WebGL have a lot of benefits. So the first one is the fact that we can generate a lot of polygons in not a huge amount of time. So for example, for every gamer here, you probably play a lot of games and there you have a lot of polygons generated, like millions of them every second. So as you can imagine, yeah, this is not based on WebGL, but still WebGL is quite good as doing that in the same manner. It's also nice because it's a web standard, and usually you also need to kind of read a 300 pages book for that to be really efficient and to understand what is happening behind. Mostly because game development is not that easy. Usually you have a lot of knowledge that you need to know before starting, and the learning curve is quite hard. So here we are web developers, so let's try to see an alternative to that, which is named Three.js. So why should somebody use Three.js? First off, you have a lot of things out of the box. So for example, geometries, lights, materials. It means that you don't really have to wonder about those things yourself because it's already included. Then you don't really need to be good at 3D. So there are no requirements of physics, math, knowing what is a quaternion, how to make matrix rotation. So as you can see, like it's hard to say, so I don't even know like how to use it. But you don't need that with Three.js, so it's pretty nice. So yeah, it also reduces the amount of code by a lot. For example, we can just check how much code do we need to write for a similar thing with the cube right now. So here we do have some simple code on how to write a similar thing in Three.js. First off, we can see that we have some styles in the top. So those are not really anything special. It's mainly just to reset the padding and the margin of the web page defaults. Then we're gonna import free. So here we are not like tree shaking it or doing anything special. Hence, the size is pretty huge. But usually you're gonna also optimize that and only pick the parts that you need. Here we do import some orbit control. So this is just to provide a camera, some default behavior on how can you move, those kind of things. We're gonna need to target a specific piece of the DOM, just to wire 3D on top of it. We're gonna create a scene, then a geometry, and we're gonna apply a mesh to it. Then we add all of those to the scene. We're gonna set the size of our window. So this is mainly used if we resize the window, that way it's gonna still adapt and take the full screen. We have the camera. So the camera will take 3 values, but yeah, mainly just like say, all right, so what's our field of view? How far can we focus? But this is not mandatory. Then we're gonna take the camera and we're gonna put it a bit backwards. We're gonna add it to the scene. We're gonna add some lights so that way we can still see things. Then we set our camera, and yep, then we set the device. The device pixel ratio. So this is basically to say, oh, if you have, for example, Retina display, it will be higher density pixels. Otherwise, it will fall back to 1 or the one that you have. And then we're gonna use tick. So a tick is something that's gonna help you do things every second or so. Depends because of your monitor. Some monitors have 60 frames per second, some have like 240. So it really depends of your monitor. But basically the tick is gonna say, oh, so we want this to happen every tick of your monitor. And basically here we're saying, oh, we have a cube and we want it to rotate into a specific speed and render then the actual object in 3D. So we are using request animation frame, which is a default browser's API thingy. And let's see how it looks. And so this is how it's gonna look. So yeah, So here I've set the wireframe to true. So if we remove that, we can see the actual cube spinning as it should. So if we don't want it to spin, we can just disable the rotation. So for that, we're gonna comment this part, and then we have simple cube that is not spinning. So as you can see, we have several lights on the left, which is hiding the other part of the cube. We can also take the cube, we can move it. So this is a basic example to just say that we can make it with only this amount of code. So as you can see, it's only like 41 line of code. And it's also like quite more usable in terms of settings. So as we saw, for example, here we can pass red, and then it will be like a red cube, which is easy, and this is more of a syntax that we are used to in JS, on top of it being only 41 lines of code. Of course, I recommend the usage of a mouse for that, because for example, if you hold shift, you can move it, you can also zoom on it, but yeah, on a touchpad, it's a bit more tricky. But here we have our cube, and if we want it to to spin slowly, we can also make it slower with just a few changes. So as you can see, we just created this cube, and the difference in terms of code is quite substantial. We are more used to it also, and it's pretty fun because we don't need to know a lot. I will now go into showing how all of this is done. But before, you need to know that all of those things can be also found online. So you have the freejs.org website where you have a lot of demos. So we're going to start by looking at some of them, but this talk will be obsolete at some point, so you can always go to the actual website of freejs.org and There you can inspect all of those amazing creations. They are usually updated every few months or so when there are a lot of new things. So yeah, feel free to check it out. So regarding some examples, here we have some websites. So this is Next.js. Sorry, I didn't really told it before, but I'm a Vue.js guy, so most of my examples will be using Vue.js. But at the same time, doing 3D is totally agnostic. And you can use pretty much anything that you like. So for this website, so this is Next3. So this meta framework for Vue.js. So it's basically like Next.js, which will bring you SSR and basically server-side rendering to your components. And here we don't have a lot in terms of 3D. We have only this small crystal or rock. I'm not sure, but yeah, since Next.js is more like themed about mountains, you can add a pretty simple rock to your website and have something, interactive that people can play with without it being too heavy and taking too much resources. We can also have this kind of thing for portfolio, for example. So this is a well-known guy that I like the YouTube videos. And so then he created this small dog where he is in front of the computer and you can play with, so you can zoom, just as we did with the cube. So this is as usable, you can just make anything that you want with it. And yeah, it's pretty friendly, as you can see. If you're more into realistic approach, you can also create those kind of renders. So those are usually asked by state agencies. As you can see, so this is a render. This is not an actual photo, but you can still see a lot of details here. So for example, we have the chair, we have the carpet, we have the various slides, the outside. We even have like some juice with a water effect. We have this one also with the chairs, the lamps, and all of this was made in Blender. So as you can expect, this is mainly used for advertisement purposes. As you can guess, there are a lot of people who will be eager to provide you this kind of renders for a good amount of cash. So if you like realism and you also want to grab some cash, you can do that also. Here, as you can see, we have Deus Ex. So this image was taken from a game. And it's pretty nice because here you can imagine that you can grab the actual weapon and change various parts of it. So add a silencer, a laser sight, or anything related. And you can also basically do that on a web page. For example, if you sell some knives and you want to change the color of the handle or add anything to it, you can do the same with Three.js. We also have this small game that was made by a French company, which is called SNCF, where the company just wanted to rebrand itself into something more accessible and quite cute. So for that, I'll just play some of the game, like pinball. That was pretty intense. We also have this game. So this game was created by a French guy who is named Bruno Simon. So as you can see, we're gonna just destroy some of the letters of his name. And this is basically a CV, a resume that he created, where he shows like what he did, like his courses, his achievements, the fact that, he loves his dog, with his dog going to the arcade. Here we have a Tour Eiffel with a French baguette, which is pretty nice. Yeah, some boating, and we can just run around, play. Oh yeah, I'm not really good at driving, as you can see. Oh man. But yeah, as you can see, you have all of this in your browser, so you don't really need to do anything special to have a small kind of game. Finally, we have this website which is aimed towards creating a nice visual for an iPhone, where you can create your own iPhone. So let's say that I want a lightning port, some cameras, and then again some cameras. So yeah, it looks pretty nice. Then we can add a home button, like an Apple logo, and Android logo. We can change the color, something, yeah, fancy. And then we have our iPhone. So how does it look? So as you can see, we have brand new iPhone that we just created in 3D with Nux.js in your browser, and you can send to your friends. Now let's move into how to do that exactly. Because this is nice. We have seen how it's made. We have saw a bit of code, but let's see exactly how it works. For that, we can go to the official documentation website again. So we can check the fundamentals and everything is explained well. We're just gonna glass over quickly so that we can still know how to use all of this without spending too much time. But if you want to know all the details, this is also a nice place. For example, as you can see here, we have the actual thing of the camera that I talked before with the focus and the field of view. But let's go back to our slides and see what do we need exactly. So for that, we're gonna need a WebGL renderer. So renderer receives the scene and the camera to render all of them down the tree. So this will wrap all the other parts. Then we will have a scene. So a scene contains the lights, the geometries, the cameras, the materials, etc. So this is basically the hierarchy, and this containing all the children and the info about where they are aiming, where they appear. So think of it as a scene in a film, for example. Then we have the mesh. So this will guide us towards the position and the orientation of each object or cube or whatever we have. Then we have the geometry. So this will indicate us if it's a sphere, a cube, a taco, a dog, a building of a conference or anything. Then we have a material. So the surface properties, for example, if like, is it shiny? Is it rough? Is it transparent? Then how basically is the surface of the object represented by a lot of variables. So those are using the BSDF principle, which is basically able to replicate any kind of material in the real world. We then need a light just to light our objects, especially if it's like metal, because metal need light so that you can see it. Texture can be used also. It's optional, but you can have that to have something more realistic. So for example, a carpet, some grass, some dirt, some rock, some, yeah, basically anything. And for example, the Twitter example with the real estate agency that we saw was quite heavy on those textures. So that way you can still see it as something realistic. So this is nice. Textures are not always free, but you can find some online. But if you're looking for something like really high quality with a lot of details, sometimes it's, yeah, you can find some of them paid. So this is also nice if you want to do something quick. Right. And all of those things that you can see here have a lot of variants with customizable properties thanks to Three.js. So you don't really need to import all of them or to even see where they are. So yeah, this is how the whole thing looks if it's more complicated. So yeah, maybe you can think, oh yeah, damn, it's pretty complex. But if you just look at it, at the end, you can see that we have some objects, we have some mesh, and some geometry and material. And this is how it looks in the most complex case that we may have. So you may think, oh yeah, there's a lot of things, but at the same time, no, we just have render, a camera, a scene, and then a group of objects. And this can represent a quite complex scene already because we have a lot of things, but at the same time, they are just linked to a geometry and a material and doesn't go like more complex than that. So it's pretty nice. What do we need for all of this? We basically need to just understand basics of JS. So we need to understand what are loops, variables, and yeah, basically how to declare a variable. Also some concepts like aliasing can help. So for example, if you're a gamer, aliasing is this thing where you can see some kind of stairs where this is not detailed. So if you understand like how it works, the internals, it can be helpful to you. But if you're a gamer, yeah, it's already there. Then understand how to navigate in 3D can be helpful. As for example, the 3D space is a bit more difficult because you have 3 axes. So when you're doing something in any kind of 3D software, yeah, it can be a bit difficult in the beginning. But yeah, understand like those parts is may be beneficial, but not required. You need some basics in math, so understand what is pi, cosinus, sinus. This can be helpful too. And overall, any kind of hardware or gaming knowledge is quite handy to optimize the code and understand the internals. So let's go back to our code. So for this next example, I want to show you a galaxy. So this is basically a galaxy done in your browser, and this is how it looks. So it's nothing really difficult because this is just like some math and some code. So we'll check the code at the end. I'll just show you how it looks. And also this nice thing on the top right. So what you can see on the top right is some control panel where you can basically increase several things. So if I want more stores or less stores, I can handle it here. And basically I just select what I want and then the browser will update regarding the details of the stores. This is amazing actually, because for example, if you have something, somebody who is not really technical and you still want to show them how it works, you can show them this web page and give them those sliders. That way they can play around with it. They can change the radius. They can put more branches, change the spin, and all of this doesn't require any kind of code. So I don't know if you prefer pink. Yeah, we can put some pink and some teal color. And that way people can just experience and say, oh, so this is how we want it. Can you please put it like that? And then you can just go back to your code and fix it the way that they want it. So yeah, pretty nice, pretty handy tool. And this is pretty performant, as you can see. You can spam the whole thing, it will not break. You can zoom on it, you can move inside of it. I remember the first thing that I saw in 3D was something where McDonald's was showcasing something like that, where you had a galaxy of burgers, where you basically gonna fly into and get those things. So how does it look for the code? So pretty much the same. We will have our styles, Free.js imported. Then we will have our GUI thing. So GUI stands for graphical user interface, and this is basically the part on the top right that we used where we showed like the various variables and how to set them. So we're gonna instantiate that. We're gonna select again for the canvas. We create our scene. Here we have all of our params that we need to set default for them. And then we're gonna generate our galaxy. So how do we do that? This is basically some math where we're gonna create a few arrays that we're gonna populate with some math. We're gonna randomize it thanks to matRandom in various places. So for X, Y, and Z. And then we're gonna have our 3D array done for us with various variables taken from the branch angle and the spin angle. So all of this is made dynamic, but thanks to JS, this is more readable and pretty friendly. We're gonna also add some colors to it. And yep, then we just set our material. So we didn't do anything crazy here, just a few things for the performance and the blending. We then add the params so that we can interact with them. And here we will also need to provide a min, max, and a step. That way we can say, oh, so this is the part where this value, and you cannot go under it because in some time it may break. For example, if we take the branches, we can go from 2 to 20. We have our sizes and then our window. So as we had before. And so this is the part where we put our camera a bit far from the center of the scene. This is quite handy because usually when you start 3D, you don't understand what's happening because sometimes you are inside of a cube, for example, and you can't see anything. And this is because you are inside of it. So we just need to get some distance to see what's around it. Then we create our renderer, we set our size. So this again for the browser. And here in the tick, we are just gonna say, all right, so we want to render the scene every time we move. So this is not something that is moving a lot as a scene, but as you can see, this is static, but we still need like to say to the browser, all right, please update it, but it's not like as heavy as you may guess. And that's pretty much all. So as you can see, this is like 180 lines of code for this whole galaxy. So we have a few lines for the positioning of the camera and the screen and the params. But the heavy lifting is done in this part with a few arrays and a bit of math. So yeah, quite handy. So you may think that this galaxy looks right. Yeah, indeed, it's pretty great. But at the same time, like, it's pretty simple still in terms of form. So, I mean, the shape of it is not like super complex. Yeah, it should be okay. But at the same time, if we want to make something more complex, do we have any kind of tool for that? And yep, we indeed have Blender. So let's see how this one works. Yeah, for a small render that takes, let's say, 50 minutes, it's pretty doable and works great. Of course, if you want to make something bigger, it will be more difficult. And then, yep, that's pretty much all. You can export it here as a GLTF. So GLTF is basically the format for the web. So you can give it various settings. But yeah, I will not get into details. Basically, just export it as a GLTF, and then we can move into the coding session part of it. So for this next part, we will use nothing special on top of that. We will just have a video tag where we position our actual webcam feed so that we can check what I'm doing on the camera. We're gonna import some machine learning. So we're going to use TensorFlow.js, which is a solution by Google to just allow us to use some machine learning without being an actual beast in math. So we import those two things. Then we can simply ask for the user's webcam, and we're gonna get the stream of it. Then this part is aimed towards machine learning. So this will basically use MediaPipe, or I mean something like MediaPipe, so that we can just check how to So this part will be responsible for detecting any kind of moves on the camera, so that if we take a specific pose with our hands, it will tell us, oh, so this on the right or on the left. We're gonna apply a small transition so that we can move. And here we're doing a bit of math where we will check, like, do I turn my hands more on the right or more on the left side? That way we can know if we want to turn left or turn right. Basically, like you are on a bike, and this is just taking my wrist as a reference. So we have my left wrist and my right wrist. So we are taking those positions, and we are just checking the direction of it. And so depending on it, either we will go straight, left, or turn right. And yep, just like this event listener from before. This is how it looks. So the first one is using Three.js journey. So this is a course made by Bruno Simon, so the guy that we saw just before, with the quad with the resume where we traveled to see like his achievements, and he will teach you how to do Three.js things like that. For example, here we can even see the the galaxy that I showed you before. And yep, he will help you know how to create all of those things. We even have, he recently also released the course on React 3D Fiber. So if you're into this, yeah, this is brand new and still like at the same price. So pretty nice. Yep, this should be pretty much your starting point if you're interested by Three.js. If you're more into Blender itself, and if you want to be more specific into that, you also have the course of Blender Guru. So this is free on YouTube, and he will teach you how to make this kind of donut. So this is how it looks. And you have a lot of materials, a lot of textures, some bust effects. And he will go from start to finish on how to achieve this kind of result. You also have all kind of creative donuts. Yeah, it shows you how Go you can and how customizable you can make it. So pretty nice. Yeah, I love that one especially. Then you also have this course. So this is Polygon Runway. This is a course that I really like because it teaches you how to get the basics well. Yeah, so this is not free, but still quite nice. He can teach you how to create some characters, how to make some landscapes, and all that other stuff. But he also have a pretty big YouTube channel where you have a lot of things similar in where you can get a lot of other free courses on how to make things. Yeah, they're pretty nice too, as you can see. Just like following the whole thing and checking how it's done in Blender with the lighting, with the textures, and pretty much everything, yeah. And the result is quite always super nice. Finally, if you're into 3JS, I can also recommend the channel of one of my friends, which is Alvaro. He's doing a lot of Vite, Next, and 3JS content. So for example, he has this whole video of an hour on how to make shaders. So shaders, it's pretty advanced topic. This is basically on how to make those specific parts. So yeah, shaders are pretty difficult overall. And it's mainly to create some custom shapes because, for example, you have the cube, you have the cylinder, etc. And a shader is a bit more specific, so it can be more performant. It can have more properties that are adapted to your use case, but it's also like a bit more low level, so it can be harder to also get right. So yeah, he can teach you how to do all of this. Mainly he did a video on Crash Bandicoot on how to make a 3D model in the same way. So if you want to get more details on how to achieve that, he's pretty good at it. That's pretty much me. So I'm Konstantin Bifert. I'm a front-end consultant in Netherlands, in Dutch company. I'm also a Nuxt.js ambassador. So yeah, I'm creating some content around Nuxt sometimes and mainly helping people. So I'm doing that usually daily on Stack Overflow. I launched a YouTube channel also recently, where we'll probably soon upload a video about the whole TRON bike. I'm also on Twitter if you want to follow some memes and some useful web development stuff or related to gaming or 3D. So yeah, I do also enjoy make keyboards, gaming, tech, DIY, and also yeah, watermelons. Like them pretty much. So yeah, that's pretty much for the talk. Thanks for listening. If you have any more questions, feel free to ask them to me like on Discord or I'm not sure where, but on the chat. I'm also totally joinable by Twitter or pretty much anywhere, so feel free to just contact me on, yeah, anywhere. Just type my name or Kiso and you'll find me. Thanks. Have a nice day.